This is Demi Birch's 6.3 Numerical Model assignment. The numerical model is similar to the technical model in the way that it analyses athlete sports performance by observing the performer and the skills and techniques they demonstrate in order to determine the ideal numerical model. This ideal model suggests what the skill should look like and how it should be executed in terms of its mechanical components. This can be looking at different angles, forces, distances and times, which are standardised units that contribute to how the skill is produced. This is achieved in a sporting context by two main components. These are kinematics and kinetics. Firstly, we should understand what kinematics and kinetics are. Kinematics is the area of biomechanics which focuses on the study of motion on a body or an object. Examples of kinematics are linear motion and angular motion, which we will explain a bit later in the assignment. But we are going to be demonstrating linear motion when performing our 20-metre sprint test and vertical jump in the data collection section of this assignment. On the other hand, we have kinetics, and this is the study of forces which act upon an object or a body which responds to create motion. Examples of kinetics include linear kinetics and angular kinetics. Firstly, linear kinetics are forces which act in straight lines. So examples of these could be gravity, mass and weight, which act as a downward force on an object. An example of this in sport is a sprinter sprinting out of the blocks. They would have the forces acting downwards upon them and a reaction force which we are going to explain later. While angular kinetics are forces which act around an axis, this can be anything that includes torque, angular forces and levers. The concept of kinetics will also be demonstrated in our vertical jump test, where we're going to be measuring the participant's power, which is a result of forces being applied on the ground beneath us and the body being propelled into the air as a resultant force. So this slide is just highlighting the two key concepts of the numerical model, and we can see through the graphs that kinetics is the forces that are acting upon an object, and kinematics is more to do with the motion of the object without really considering the forces that are acting upon it. So there's a clear distinction between the two. The numerical model takes a quantitative approach, which is the idea that it uses numerical data to produce quantitative data that can be analysed and compared against a perfect numerical model. This is because the numerical model is very involved, as it requires analysts to focus on the standardised units such as distances, angles and forces, which are all quantitative values. As this assignment is following a basketball approach, and the numerical model focuses on the physics of how athletes, and specifically basketball players, require power, speed and forces in order to perform well in their sport, we can show how this would be conducted through basketball. Firstly, the analyst will decide on the criteria they will be observing. For example, in basketball, an athlete's power, or the force they generate from a jump or rebound. From this, they would devise a fitness test to measure the criteria and gather video footage and data from this. After the data has been gathered, software will then be used to interpret the findings by using graphical representations, tables, charts, and pieces of software in order to overlap images and determine angles and forces. And this can also be compared to elite performers to see the differences between the two performers. So this technique focuses more on the biomechanical aspects than the other models, but this is very important in very technical skills that have a fine line of margin in how the skill should be executed. When producing a numerical model, there are a variety of different methods that can be used in order to gain knowledge about how the different mechanical skills play an important role. This is done through the use of sources, which can be used solely on their own, or combined with a more interactionist approach in order to produce the perfect numerical model. Firstly, we can create a numerical model by using literature that demonstrates normative data. We are actually going to use your normative data, when conducting our 20-metre sprint test and vertical jump test. So in order to determine a numerical model for these tests, we could use the literature to explain how on average people of a certain age group should be able to produce a certain amount of power or run a certain amount of distance in a certain amount of time. Because these tests are standardised, and another example of a standardised test is the bleep test. A more standardised test provides a more objective and standardised view, so it's easier to be replicated. And this is why so many researchers and people in general have been able to replicate these tests in the same way. And from this means we can trust the data that has been produced, and the results therefore are more scientifically credible, which can help to make suggestions when performing and forming a perfect numerical model. Alongside literature, we can also look at specialist sport-related research and academic journals. The reason why academic journals can be used in order to create a numerical model is because of their high scientific credibility. This is because journals are normally peer-reviewed by academic specialists. This means that it has been reviewed by experts in the field of that subject to make sure that the quality, relevance and accuracy is effective, and therefore has the ability to be published. They also check the procedure, the method, the conclusions, the whole experiment as a whole to make sure that the methodology is sound. So from this then, we can conclude that the information is of high quality. As this assignment is on biomechanics, and in order to create a numerical model to represent this by using academic journals, we could look at journals that had been specifically reviewed by biomechanists. And in this, therefore, this would give us a higher reliability for using that research, as it has come from specialists within that sport. So we have a more accurate interpretation of the research and the results to make them more scientifically credible. Also, we can produce a numerical model through observing elite performers and how they execute a particular skill. This can then be inputted into software, which can then manipulate the footage to slow it down and replay it, so the analysts can then identify the numerical values for the particular skill, which can then be used to calculate units like speed, velocity, distance and power. An example of this could be observing a layup in basketball. The analysts would be observing ideas like the distance needed from the basket in order to produce an accurate shot, the speed the athlete is travelling, perhaps from one end of the court to the other, when the differences in jogging back to position or sprinting back for a turnover, the angles they are taking the shot from, and the angles needed in order to produce the shot technique. We can also use elite level results from their sport. An example of this is in basketball. The website Top End Sports provides us with the data for different fitness tests of the NBA elite athletes. So from this, we can then determine the perfect numerical model by using the data from the NBA elite players against our basketball performers to demonstrate to the performers what they should be achieving based upon elite standard. So it gives them something to aim towards. Another method which is very similar to elite athletes is using specific athletes to that particular sport. And in this assignment, we are actually in fact going to be using the NBA draft data scores in our analysis against our chosen performers from the 20 metres to sprint and the vertical jump tests to denote a perfect numerical model for our chosen performers. It can help these performers then to develop the skills needed by comparing their score from the test to the elite players. In terms of their biomechanics, what they need to improve to replicate the way the skill has been presented based on the data from the elite performers in that sport. There are also more simpler ways of gaining knowledge when creating a numerical model, and this can just be from using blogs from perhaps people that have an interest in the sport or player or coach. And this can also be shown through websites like Wikipedia and YouTube videos that have been created to demonstrate the perfect numerical model of how skills should be performed. However, when using these sources, it is important to know that we must be aware that these sources are much less credible than those like academic journals and literature, especially the ones that have been peer-reviewed. This is because the people who make the blogs or videos to put the information out may in fact not be specialised in that area of biomechanics of that sport, and therefore their knowledge may not be as reliable as it's based on first-hand experience or their own opinions. So by using this data is quite subjective, whereas the academic journals and literature are more objective, so they're more scientifically credible. So it's just important to be aware of the credibility of the sources that we use. And this slide is just showing, as I've explained, the different ways that we can create it. So using journals, literature, specifically ones that have been peer-reviewed, the websites, maybe the less credible ones, normative data, as we've said, from using elite athletes as well as just average scores, websites and videos from governing bodies, so this is the NBA, so this would be quite credible, and then elite athletes themselves. Adding to this slide, these methods can also be used in combination with each other, and by taking a more interactionist approach will allow you to gain knowledge from a wider range of sources to provide an overall better rounded numerical model. As just from using one type of source may limit your knowledge, and just by gaining one perspective may not necessarily be the right way of performing the skill in terms of its biomechanics. So perhaps by using academic journals alongside elite performers or specific base athletes will give a much wider overview, and then you can decide perhaps for yourself or to suit your athletes which parts are more important to form a perfect numerical model. This can also help depending on the difficulty and complexity of the skill, as for example in basketball a layup shot is one of the most difficult shots to achieve. So from viewing elite athletes' data from fitness tests to show their power, and then from analysis of angles, the distance and the time can really help to show an amateur basketball player how to replicate the skill and use the elite data to improve their own skills, which are relevant when performing the layup shot. So as we've mentioned about basketball, important skills in basketball to have is power, speed, acceleration, because basketball is such an explosive sport. So just by looking at the results from the NBA data, we can see that roughly what sort of power and acceleration we should be aiming for when being a basketball performer. So it shows an optimistic view of what these performers should be aiming for if they want to be performing at the standard of elite or towards that standard. So moving on now, we're going to be looking at the types of motion. As we can see on the screen, there are 3 types of motion that can be identified when observing different sports. The first example is linear motion, and linear motion is where an object or body travels in a straight or curved line with the same speed, in the same direction, with the same distance to move in the same way. An example of this, as shown on the screen, is in the skeleton, the winter sport, where the body of the performer and the bobsleigh remain in a linear position the entire time, where they are flat on their stomachs to produce the streamlined shape to help increase their speed. So they are moving at a constant speed around the course, and this position that they achieve will help to make them more streamlined and to keep that constant speed. Another example is angular motion. This is when a whole body or certain appendages rotate around a fixed centre of rotation or an axis in a circular motion. For example, this can be shown through a gymnast on the horizontal bars when they rotate around the bar, which is the fixed position. To understand how in angular motion our speed can change, depending on how far we are from the fixed axes, if we look at this example of diving, a diver will tuck their head into their chest when performing a tucked somersault to increase rotation. So therefore, because the diver is increasing their speed by shortening the distance between the external points, like their head and the centre of rotation, so they can spin faster in order to successfully complete the necessary turns. Whereas if the diver doesn't tuck in their head enough, they will decrease their speed as they are lengthening the distance between the centre of rotation and their external points. So this will make it harder for them to rotate. So this is very important in sports.